Hi, we are Group 4, and today we'll be presenting our project on interior routing protocols and their implementation. Our group members are Yash, myself, Satwinder, Isha, and Aryan. For this presentation, I'll be giving you an overview and the introduction and the network scenario before my teammates continue with the technical details. I'll start with the overview. Our project focused on designing and stimulating a multi-campus university network using Cisco Packet Tracer. We applied IPv4 addressing with /28 subnetting and configured our IP version 1 as a routing protocol to connect our four different campuses. The main aim was to establish end-to-end connectivity, validate the setup through testing, and reflect on the challenges of fixed size subnetting in real-world environments. In short, the project not only gave us the hand-on experience with the subnetting and routing, but also helped us understand why design choice like dynamic routing protocols are important for scaling networks. If I go on with the introduction, universities today rely heavily on a network infrastructure to deliver teaching, research, and administrative services. As a single day involves activities like logging into the LMS, attending Zoom and Teams classes, accessing online libraries, and connecting through Wi-Fi. For multi-campus universities, strong inter-campus connectivity is critical. The network must be reliable, scalable, and secure. In our case, we were given a Class C block, um, 192.172.9.2 slash sorry 9.0 slash 24, and tasked to divide into /28 subnets. Each campus was designed with a router, a switch, and two PCs, with while the campuses were connected through the serial WAN links. Instead of manually configured static routes, we implemented RIPv1. This allows routers to automatically share route information and
Hello, my name is Isha. My student ID is 2023939. Today I am here to represent the group assessment of NTW302. As Satwinder already discussed about the topic of the assessment, so my part is like introduction. For the introduction, I can say that networking is very crucial for universities, as because of computer network they can connect their devices to each other, and after that IPv4 subnetting provide the address efficiency. Then dynamic routing ensures the scalability to the networking, and RIPv version 1 is very simple, educational, and professional. So let's discuss about the network scenario. So we just get four campus for the university: campus 1, 2, 3, and 4. The base network of the campus is based on the group number. My group number was D, so we just add 5 to the D, like it's 9 now, so it's 192.172.9.0/24. It's Class C base network. It has 4 campuses having the components like routers, switches, PCs, and serial WAN links for the interconnection, routing, RIP version with as routing protocol. So for the topology design, we can say that router R1 and R2, switches S1 and S2, partial mesh design for balance, consistency in interface name, resilient and efficient lab setup. For the subnetting address allocation, it's 29 fixed subnet used, 28 fixed size subnet used. Each LAN and WAN gets /28, 14 usable addresses per subnet. Validation, ARP and routes. Thank you so much.
Hey, my name is Yash Kangas, and as my friend Satvinder already started the assessment, the presentation, And then my friend Isha moved on to the some other stuff like packet tracer design and stuff, design specifications and stuff. Now it's my part, and I'm going to talk about subnetting and two more topics that are going to come forward. So first of all, let's start with subnetting. So in this assessment, we were told to design, we were told to work on a university which has different campuses, and we took four campuses on different locations, and each campus had one router and one switch with two PCs to showcase how different campuses could work. And we connected them together, and we used subnetting to make sure that the contents of one campus are safe. Like it can be the subnets can be made of fixed sizes, so it's more usable. Like here we have created /28 fixed size subnets. We have each LAN and WAN will get this one. There will be total 14 usable addresses per subnet, and we will have validation with pings, ARP, and routes. The screenshots are already attached in the report that you can check. Moving on to the next slide. So why are RIPv1 configuration? Because it is really simple to set up for dynamic routing, and it broadcasts routes every 30 seconds. So it gives updates to all the nearby routers and update their routing tables. And the hop count for RIP is maximum 14 hops. If there is a hop which is number 16, it will become infinite and unable to reach, and it can be configured on all routers. These are some characteristics of RIP configurations. Now maybe we on to the practical implementation. So total, as I already mentioned, we have four routers, four switches, eight PCs, and we have divided them on four campuses of the same university. So they are connected with wires and stuff in different campuses. And we have already configured addresses, enabled RIPv1, and all the configuration screenshots are provided in the report that you can check. And we have also provided the packet tracer file that you can also check. Now my friend Aryan will complete the rest of the slides. Thank you for watching.
Hi everyone, my name is Aryan and I'm a member of Group 4, and today I'm going to present on interior routing protocols and their implementation. So I'm going to start with the testing and validation. To validate our design, we performed connectivity tests using ping commands across different campuses. All pieces were able to communicate successfully with one another, confirming that RIP routing was functioning properly. This proved that our subnetting and configuration were correct. So in this slide, we will discuss the drawbacks and challenges. While working on this project, we faced some challenges. So firstly, RIPv1 has limitations such as no support for VLSM or IPv6. Second, configuring serial links required careful attention to clock rates and IP assignments. Finally, troubleshooting rerouting issues required us to check configurations step by step, which was time consuming but very educational. So lastly, in conclusion, we successfully built a four-campus network, validated connectivity with RIP1, and gained practical experience in subnetting and routing. Secondly, for future improvements, we would recommend using VLSM, upgrading to OSPF for better scalability, and exploring IPv6 adoption. Thank you so much for listening.